audio from my.
Guys, can you hear me now clearly? Hello.
Yes, we can hear you.
Thank you very much.
Yeah.
So in 1980s, Hinton and David and Rummerhold and Ronald J. Williams they came up with the back propagation algorithm popularized by Ronald and addressed the limitation of single layer perceptron by enabling multi-layer networks to learn. And in 1982, John Hopfield introduced Hopfield network, which could save a content addressable memory systems with binary threshold nodes. And then, so from 1990s to 2000, it was the emergence of machine learning as a field. So now it has come up again. And then in this period, we have mostly the topics that are being researched on support by vector machine, decision tree, and ensemble methods. So in the 1997, it was a long short-term memory LSTM, significantly advancing the field of recurrent neural networks. That means from LSTM and then I mean say from RNN it was advanced to LSTM, and then from LSTM it has gone to GRU. And then in 2000 to 2010, Hilton, Simon, and EY Tech. I'm sorry, please bear with me for the pronunciations. It's 2006, Joe Free, Hiten, Simon Osindiro, and EY Tech. These are the popular researchers who has what to call come up with a paper in a fast learning algorithm for deep belief nets, reigniting interest in the deep learning networks. And in 2009, Fei Li launched the ImageNet project, creating a large-scale dataset for image recognition, which became a benchmark for evaluating the performance of deep learning net models. So can anyone give me an example of this?
We can see your screen.
You can see more.
See only this.
It's not moving?
No.
Even you also can't see the screen?
Now
Oh,
you
that
can
is...
see from here, but we cannot.
Guys, can you see the slides moving?
No, the slides are not moving, Professor. Your alternative is to click on the slides on the left. We are able to see your both your layout view as well as the presenter view. So to move, just click. Yeah, now it's good. Yes.
That's fine. That's fine. Okay. Oh God.
Okay, relax.
Yeah, this mode is good. You can just navigate from the bottom.
And just continue. So in the modern era of 2010 presence, coming here, it is related to a very deep convolution network by Keming He introduced residual learning, allowing for the training of much deeper networks. And in 2017, the transformer model introduced by Vaswani revolutionized natural language processing NLP by enabling models to handle long-range dependencies more effectively. And in 2018, OpenAI, Google released large-scale pre-trained models like GPT-2, that is ChatGPT-2, and BERT, respectively, which demonstrated the power of transfer, learning, and pre-training on vast data sets. And in the year 2020, OpenAI ChatGPT 3 set new benchmarks in NLP, which is ability to perform a wide range of tasks without fine-tuning, showcasing the potential of large-scale language models. So now, in the key developments and trends, if you see, as far as the hardware is concerned, the advancements that we can notice is the development of GPU and DPU has been critically for training large-scale deep learning models efficiently. And then in the data availability of large data sets and improved data collections methods having been crucial for training robust models. And in software frameworks, the creation of deep learning frameworks such as TensorFlow, PyTorch, and Keras has made it easier for researchers and practitioners to develop and deploy models. And in applications, if you see, machine learning and deep learning are now ubiquitous, which applications in fields such as computer vision, NLP, healthcare, autonomous vehicle, finance, and more. So a simple methodology that is being implemented for the review. There is no typical or particular methodology that I had taken into consideration while doing this review. So if you can see the it's like block diagram, it starts with start exploring resources first, where you have to check your resources. That could be your any specific tool that you know, or you can go for a Google Scholar, which is the best one that is available on the online in Google. And then you can also go for your university digital library. And from there, if you try to browse for there are so many publications, which are, some of them are Springer, IEEE, Elsewhere, ACM, ResearchGate, and so on. So once you try to figure out what kind of publications you want, you can just search for those publications. And after that, you can start collecting it. But when you try to collect, so you need to provide even the domain and the keywords. So the domain based filtration you have to do in the search field, where it could be depending upon your specific topic. Either it can go into a SDN, software defined networks, or IDS, intrusion detection systems, wireless security, cybersecurity, etc. These keywords which I had selected is related to cybersecurity. So that's the reason I had mentioned those. And those from different domains, they can select their own domains. And then segregation based on AI, ML, and further that can be narrowed down. So whatever specific area you are looking at, it could be as an algorithm, it could be as a technique, or whatever it is, you can find out. So in my case, I had selected DNN, RNN, GRU, CNN, LSTM, and ML. And likewise, if you go for a collection based on combination of year and number of citations, so this can further narrow down your search using number of citations. So if you go on to Google and use those phrases or some sort of keywords, a list of links will be provided, that are being displayed by the Google search engine, where you can see particularly at a citation that they had been the numbers, like it can be varied from known citations to more 100 and more than that. So based on that, you can select your paper with respect to the above parameters that you are looking for. And then likewise, you can also scrutinize your search, or you can narrow down your search based on your year wise. So if you want to search for the last 5 years or 3 years or whatever it is, you can fix that in the left side margin. This is especially in the Google Scholar I'm talking about. If you have your own tool like a Cywall or something like that, even they do. They also provide similar kind of features where you can set your filters over there. And then once you have got all the filters in place, you can just start browsing or exploring the list of papers that are being displayed. And once you have that, further you can pinpoint those papers where you're looking exactly in your topic based on an abstract, which could be an abstract and which could be a research gap. In the paper itself, they will be providing you. It is not on the face of the paper you can find the research gaps, but however, you can try to figure out the research gaps that the author has discussed about. And abstract is also same thing. And further conclusion also. In the conclusion, they always provide a future research. So from that also you can make out whether that paper is very much supportive for your research or not. And then review of IDS based or rule based. So IDS are basically depends upon the rules that we set. For the best example I can say is in the firewall, if you can set the inbound, outbound traffics, you go through a lot of rules. So the same thing over here, but in a specific manner, and most probably it can also include some sort of heuristic research, or you can also it's like what you call a heuristic say fuzzy search based on that particular condition. If it satisfies that particular threshold, then it will be filtering those, and depending upon the action that you had mentioned over there, either it will drop it off or it may provide it into a channelize into another folder or whatever location that you direct it. So that is how actually the IDS based rules are working. And then a review of a ML technique. So if you see the simple example I can give you related to the ML is that in your mail, actually you can see the spam mails. And at the same time, if you see the traffic that is coming into your system, at that point of view, you can also check how the packets are coming and how it is being classified. So most of the time, the ML, it does it on its own. And it is based on the training and validation data that is provided to it while the model is running. So it depends upon the amount of incoming packets, and at the same time, the features or the parameters that you had provided. And at the same time, when you had run the model, it is also depends upon the amount of training you had provided on the existing data. So altogether, based on it has some calculations and computing, which will classify whether it is a malicious packet or if it is a genuine packets. So that is how ML works. And if you see further, you have a supervised ML, unsupervised ML, semi-supervised ML, and reinforcement learning ML. So what are there in the learning supervised ML? I'm not going into deep of this. I'm just giving you a one-line answer, so you can just try to understand. So linear regression, it is applied in regression problems, and the logistic regression, it is applied in the binary classification problems, and then a decision tree applied in both classification and regression problems. Supportive vector machine, SVM, that is in short, is used for classification tasks, and which we can correlate to the previous slide, which I had provided you the example with the diagram, how the packets are classified. And then the k nearest neighbor used for both classification and regression tasks. And then naive base used for classification problems. Unsupervised ML, it is a machine learning type which a model is trained using data that does not have labeled responses in this approach. So the algorithm tries to learn the underlying structure or distribution in the data to uncover hidden patterns or groupings without any prior knowledge of the outcomes. They are used for mainly clustering purpose, like hierarchical special big data, images, health records, network logs, etc. So what exactly is the difference is that most of the time you don't have labels in the data that is used for unsupervised machine learning. So the labels that do not have it's like means it's like a raw data. So as a it's like you are taking exact the raw data and then trying to apply these models and then trying to find out the differences. So it has to either scrutinize or classify or clustering. Mostly the word they use is clustering because of the difference of this difference. Okay, and then partition data into k distinct clusters, k means, and then hierarchical clustering builds hierarchy of clusters, and then principal component. And one of the parameter why they use unsupervised is that dimensionality reduction. So principal component analysis. So because the main problem over here is in the supervised MLs, you have a labels where you can either select manually, or you can it's like use some computation, and based on that you can just straight away it's like reduce the dimensionality of number of features that can be considered depending upon the parameters that you are selecting. Maybe it can be some dependency parameters or straight away parameters. But whereas absence of the labels, because you doesn't know what parameter labels that the raw data contains, you have to just try to make sure that the dimension of the selection of the parameters can be reduced. The reason behind is that it's like it will take very long time for the training and at the same time computing if you use the whole parameters of the raw data. So that is the reason why they go for principal component analysis. And then semi-supervised ML, it is a type of machine learning that falls between supervised and unsupervised learning. It involves training a model using a combination of a small amount of labeled data. This approach leverages the abundance of unlabeled data, which is often cheaper and easier to obtain while still making use of the labeled data to guide the learning process. These are used in detection, identification, and recognition of spam mails, images, speech, etc., along with clustering these huge data into required categories. Label propagation applied for methods to spread labels from labeled to unlabeled data. So as we had seen, unsupervised and supervised, this semi-supervised fall in between these two. So when you have a very limited known parameters that would be considered as a supervised, and then you have no idea which is about the data that is similar to it, you can just mix both of them and then try to extract as much as information from the unsupervised data, and then train them simultaneously, and then try to compute as per the model or the algorithm that you are using over here. So hierarchical cluster it's almost the so principal. So we have label propagation applied for methods to spread labels from labeled to unlabeled data. And hierarchical clustering builds a hierarchy of cluster using either a top-down or a bottom-up. And then semi-supervised support vector machines extends SVMs to handle unlabeled data. Principal component analysis, as I explained as just now, and independent component analysis (ICM) separates a multivariate signal into additive, independent, non-Gaussian components. So the last category which we have is reinforcement learning, machine learning. It's a type of machine learning where it learns to make decisions by performing certain actions with an environment to maximize some notations of cumulative reward. Unlike supervised learning, where the model learns from a data set of labeled examples, reinforcement learning is based on the idea of learning from interactions with the environment, which means that based on the environment of that particular data that you are using, it tries to learn, and then maybe it could be the variation in the traffic, or it could be the time stamps of the traffic, which could be the environment variables. And in Q learning learns the value of state action pairs, aiming to find the optimal policy by iterative updating Q values. And then proximal policy optimization, a policy gradient method that balances exploration with stable updates. Actor critic methods applied for two models, an actor policy and a critic value function to improve learning efficiency. And now coming to ML applications. So we have facial recognition, fingerprinting authentication, automatic attendance systems, handwritten recognitions, fraudulent signatures, voice interface and voice assistance, translations to text-to-speech, similar language translations, pattern recognition, data mining, traffic prediction and transportation networks, statistic analysis of medical documentation images, banking and fraudulent transactions. So to put them in the proper phrases, in this new era of technology, security is the most important domain where ML is used for facial recognition, and iris scans are in high demand along with fingerprinting authentication. ML-based facial recognition technology is used to identify extremists in crowded places, ranging from visitors at airports to participants at mass gatherings or ceremonial events and other high security settings. In educational institutes, ML is employed in automatic attendance systems within the professional institutes, providing a more secure alternative to conventional methods such as keys and identity cards, which can be easily stolen. So instead of that, you can use ML. And then handwritten recognition applications facilitates the process of large volumes of handwritten documents, particularly in universities, exam centers, and police investigations, where verifying fraudulent signatures and question documents is essential. So question documents, in a sense, like it could be litigation documents, it could be any sort of legal documents. ML is also used in speech recognition, which translates spoken words into text and offer numerous benefits across various sectors in healthcare, military, and automated systems. It helps create voice interfaces and voice assistance, improving accessibility. Additionally, speech recognition supports language translation, easy communication barriers. Machine learning is widely applied across various domains, including robotics, virtual personal assistance, video games, pattern recognition, natural language processing, data mining, traffic prediction, transportation networks, product recommendations, stock market forecast, medical, and so on. So, and now we review of deep neural network. So you have over here in the block diagram, on the face of it, you can see input layer, nodes, weights, and output layer. So the hidden layer is where the end nodes are connected, and you have weights on them, WI1, WJ1, and so on till WI and WJN. And you got a summation of W, that is weights, based on which the perceptron and the new will be calculated. And an activation function is being triggered over there, and with the bias parameters, and then finally the output of the and input data is being given over there. In more precisely, if I say deep learning uses artificial neurons that mimic the human brain. A perceptron or artificial neuron receives inputs with assigned weights, computes a function, and provides an output. This figure, as I explained, illustrates the structure of a deep neural network. Inputs are summoned, transformed by an activation function, and produce an output with input significance determined by weights. Adjusting the bias parameters fine-tunes the output of each perceptron. Activation functions such as sigmoid, tanh, ReLU, and softmax, and there are still more, transforms inputs into output. Multiple neurons are used together to process complex inputs and reach conclusions. So what are the categories that are present? So similar way that we had in ML, the same way we have in this deep neural network. Supervised deep neural networks, deep feed-forward networks, multi-layer perceptrons, LE-net, LXNet, VGGNet, RESNet, and Inception GoogleNet, MobileNet, etc. So it's a powerful type in realm of AI capable of tackling complex stacks where a model learns to map input data to output labels through multiple layers of neural network. This comes under supervision because it relies on labeled data sets where the input data is paired with the correct output. So deep feed-forward network extends MLBs, multiple perceptrons with more layers to multiple layer perceptrons with more layers to capture complex pattern in the data. multiple layer perceptron. This simplest type of DNN consists of fully connected layer where each neuron is connected to every neuron in the next layer. And then LENet, one of the earliest convolution neural network architecture designed for digit recognition. So this is where the CNN has come up for. In the initial stage, they had used it for recognition or identification of the numbers. Most probably, I believe even Turing has also used it for this purpose. The first machine learning to identify the signals of the numbers that can be traced. And then LENet, one of the earliest convolution neural network. So AlexNet, a deeper CNN that won the ImageNet competition in 2012, sparking widespread interest in deep learning. So the LENet is been extended further, and then that is as like what to call designed into an AlexNet, which is specifically used for image identifications and recognitions. And VGGNet, known for its simplicity and used of very deep neural networks with small convolutional filters. ResNet introduces residual connections to allow training of extremely deep neural networks. And then Inception GoogleNet is a combination of a convolutional with different filter size to capture diverse features. MobileNet optimized for mobile and embedded vision applications by using depth-wise separable convolutions. So unsupervised, we have autoencoders, basic autoencoders, denoising autoencoders, sparse and autoencoders, variation and autoencoders, sorry, generative adversarial networks, and basic GANs. So unsupervised DNN, it is designed to learn patterns and representations from data without explicit labels. Techniques of generative networks, dimensionality reduction, and clustering are frequently counted with this category. So what does an autoencoder does? So it is a neural network that learns to encode the input data into a compressed representation and then decode it back to the original data. So basic autoencoders consist of an encoder and a decoder with a bottleneck layers in between. So denoising. So actually these encoders, actually they are used for encoding mostly into a binary format and then again decoding into the original format of the data sets that are used. Denoising autoencoders trained to reconstruct clean input from a corrupted version, enhancing robustness. Sparse autoencoders use sparsity constraints on the hidden layers to learn more meaningful representations. Variational autoencoders learn probability latent representation, allowing for generating new data samples. Generative adversarial networks. It consists of two neural networks, a generator and a discriminator, that compete with each other. Basic GANs, the generator creates fake data samples while the discriminator distinguishes between real and fake samples. And there is another one more technique that does the similar way. So which I will speak in the last. And then semi-supervised DNN, improved generative adversarial networks, mean teacher, virtual adversarial net training, self-training with confidence thresholding, label propagation. Semi-supervised DNN, it leverages both label and unlabeled data to improve learning performance, especially when labeled data is scarce. The key type of techniques used in semi-supervised DNNs are improved generative adversarial networks, the discriminator not only distinguishes between real and fake samples, but also classifies real samples into their respective categories. Mean teacher involves a teacher model and exponential moving average of the student model, providing stable targets for the student model. Virtual adversarial training regularizes the model to be robust to adversarial perturbations of the input. Iterative pseudo labeling continuously updates the pseudo labels as the model improves during training. Self-training with confidence thresholding only uses pseudo labels for sample where the model's prediction confidence exceeds a certain threshold. Label propagation, labels are propagated through the graph based on data point similarities. Okay. So you also have the similar kind of deep neural network applications as compared to ML. So big data, chart GPT, NLP, LLM, large so it's like LLMs, image data sets for graph-oriented tasks, AI-driven vehicle technologies in the medical domain, image segmentation, object detection, navigation without maps, tiny ML in IoTs, various cyber network attacks. So for from the statistics of Cloudflare, the same slide I'm using for the next paper also. It is clear, or otherwise I'll do one. I'll skip this now and I'll just do that in the next paper. So from the above introduction, history, implementation methods, exploring and studying, literature review, IDS rule-based review, ML review and applications, DNN review and applications and Cloudflare. Q4 2023 statistics underscore a pressing need to explore additional procedures, methods, techniques, approaches, and innovative combinations resulting in hybrid models using these DNN and ML techniques to prevent DDoS attacks entirely or minimize their impact. Consequently, the aim is to examine existing techniques and provide a comprehensive review in the form of a